binomial distribution, we've been talking about probability distributions, and the binomial distribution is a special one. It has a number of characteristics that you can tell it's binomial. One of them, the word binomial, and bi meaning two, only two possible outcomes. And those outcomes are commonly called a success and a failure. Now, if you toss a coin, that could be considered a binomial event. In fact, there's only two outcomes, a head and a tail. Now, don't jump to too many conclusions, because rolling a die could also be a binomial event, because it could be the possibility of throwing a 6 or not throwing a 6. So throwing a 6 would be 1 chance in 6, not throwing a 6 would be 5 in 6. So once again, you could have success and failure with rolling a die, even though there are 6 possibilities when you roll a die. But if you're particularly interested in, say, the number of 6s or the number of 1s that you throw, then that would be considered to be a binomial situation. Now, with only two outcomes, probability of success, probability of failure, you know that the probability of a success plus the probability of a failure has got to be equal to 1. There are only two possible outcomes, a success and a failure, so when you add the probability of each of those, you're going to get 1. We have a number of repeated independent trials, and we use the letter N for how many there are. So independent means that when you do it for the third time, it has no bearing what happened on the first, second time as to what happens on the third time. So they are independent, it's repeated over and over again. So if you toss a coin 3 times, well, the number of trials being independent of 3 trials. So they are the main characteristics of what goes to make a binomial distribution. So let's just look at a quick little example. So suppose you perform an experiment 3 times, and the probability of a success is equal to 2/3, and the probability of a failure, you know what it is, 1 minus the probability of success, because these two got to add up to 1, so the probability of failure must be 1/3, because they've got to add up to 1. Alright, if we had a look at 2/3 plus 1/3 all raised to the power of 3. Now we know that when we add 2/3 to 1/3 we get 1, so that is 1 to the power of 3 is going to be equal to 1. But if we know our expansion for, say, a plus b to the power of 3 will be a to the power of 3, so that's 2/3 to the power of 3 plus 3 a squared b, so it'll be 3 2/3 squared b plus 3 ab squared, so 3 2/3 1/3 squared plus b cubed plus 1/3 all raised to the power of 3. So that's just an expansion of a plus b all cubed, going back to some high school maths there. But if we look at this, this is 3 successes, the probability of 3 successes. If you have 3 successes, you must have 0 failures, because probability of 1 success is 2/3, so if you go to the power of 3, that's 3 successes. This is the probability of 2 successes one failure. Alright, so that's 2 successes and 1 failure. But why do we need the 3? If you get 2 successes and 1 failure, how many different ways can you get that? Well, you could get success, success, failure. That's 2 successes and a failure. You could get success, failure, success. Or you could get failure, success, success. So there are 3 ways you could get 2 successes and 1 failure. And that's why we've got to multiply that by 3. This is 1 success and 2 failures. Similar type of logic behind why we've got to put the 3 there. But that's the probability of 1 success. This is the probability of 2 failures, because 1/3 is 1 failure. And then we multiply by the 3. And this is 3 failures. And if we worked out what that is as a fraction, worked out what this is as a fraction, that is a fraction, that is a fraction, and added those 3 up, we would get 1, which is 2/3 plus 1/3, 1 raised to the power of 3 is 1. So when you add up all those, you should get 1. All right, now, it would be good to be able to do some sort of generalisation given n trials and being able to write down a probability of R successes. Here we've got 3 successes, 2 successes, 1 success, and 0 successes, 3 failures. So let's just work out a way that we can actually go straight to it for working it down. Before we do that though, look at the coefficients here. We've got a coefficient of 1, 3, 3 and 1. And I'm sure you're familiar with Pascal's triangle. And Pascal's triangle always starts with a 1 and starts and ends with a 1. And then starts, ends with a 1. And then to get the intermediate, we add those 2 together. 1 plus 1 is 2. And then 1, add those 2 together, 3, 3, and 1. Here we've got the same coefficients, 1, 3, 3, 1. So this will be P plus Q to the power of 0, P plus Q to the power of 1, P plus Q, we'll use the coefficients for that, to the power of 2. Now if you know your expansion here, this will be P squared plus 2PQ plus Q squared. P squared has a coefficient of 1, 2PQ, you get the 2 there, plus Q squared, which is 1Q squared. This is P plus Q to the power of 3, and we refer back to doing the expansion here. These numbers here give us the coefficients 1, 3, 3 and 1, so, and so on. P plus Q to the 4 would be 1, add the diagonal there, 4, add those 2, 6, 4 and 1, and let's go one more. P plus Q to the power of 5, start with 1, end with 1, add those 2, we get 5, add those 2, 10, add those 2, 10, 5, and you can see there's some symmetry going on here too. So this would be if P was a probability of success, Q is a probability of a failure, and you perform an event 5 times. If we were to write out the expansion of P plus Q to the power of 5, P plus Q to the power of 5. Alright, here we've got a coefficient of 1, and we'll go, just looking at what we've done up above, we've got P to the power of 5 plus, so we're going to do the expansion of this and write down all the terms. The next coefficient will be 5. Now the general pattern here is that the powers of P go down by a power and the powers of Q we could have had q to the power of 0 there. Anything raised to the power of 0 is 1. So p to the power of 5 will go down a power, and the powers of q will go up a power. Plus, the next coefficient is 10, so we've done the 1, 5 here. So the next one's a 10. Powers of p go down, p to the 3, q to the power of 2. So the q's are going up, the p's are going down. Plus 10, p's going down by 1, so that'll do 2, q's go up 3. Plus 5, p to the power of 1, q to the power of 4, plus 1, q to the power, that will be p to the power of 0. Anything raised to the power of 0 is 1, so we don't need to write that in there. And q to the power of 5. Normally we don't write the 1 between those. But you can see that when we add the powers, we should always get 5, 4 and 1, 3 and 2, always get 5. And the p's go down, q's go up. So what is this? This is the probability of getting 5 successes. This is 4 successes, 1 failure, 3 successes. This is if the experiment is done 5 times. And you would be given the values of p and q. P would be the probability of success, q is the probability of failure. This would be the probability of 3 successes and 2 failures, and so on. 0 successes, or another way to write that is 5 failures. All right, so that's how to work out with 5. But say we perform an experiment n times. That is, there are n trials. P is the probability of success. And Q is the probability of a failure. We use little p for success. Little q for probability of a failure. What's the probability you get R successes? Now, without having to write out the whole lot, this, go back up here, this is 4 successes, this is 3 successes, 3 successes, 2 failures. So the probability of R successes will be P to the power of R. And we've already worked out that these must add up to the number of trials. So this was done 5 times, so it was to the power of 5. So what have we got to add that to get the number of trials? Now the number of trials was n. So if we add n minus r, when you add those two together we get n trials. So the last thing remaining is to get the value here of the coefficient. So this would be r successes, n minus r failures. Okay, so we just got to work out how we can work this out. If we go back up here, we have done combinations before. So this actually turns out to be 5C1. This also is 5C1. 5C0. And this is 5C5. And this is 5C1 here. And this is 5C2. And this is 5C3. And that's 5C4. And that's 5C5. So 5C1 is 5. You could work it out doing the calculations with factorials. 5C2 is 10. 5C3. Don't forget that NCR equals NCN minus R. So that's why 5C1 is the same as 5C4. And that's why 5C0 is the same as 5C5. So if we look here, so this is 5C1, this is 5C2. and that's 5C0, 5C1, 5C2, and that's 5C3, etc., etc., etc. So this here is NCR. So this is the number of successes that you're going to get. This number here corresponds to that number up there. So that's the probability without having to work out every probability. If you were asked a particular questions, a coin is tossed 20 times, what's the probability of getting exactly 10 heads? Well, it would be 20, see 10, a half to the 10, a half to the 10 there too. So you'd have 10 heads and 10 tails, and you could work that out. The next thing is we've been doing some work on mean and variance. So the mean is worked out by just NP. So the number of trials by the probability. The variance is equal to NPQ. So these are two rules that we need to know for binomials. We need to commit those. Standard deviation, we know, is the square root of the variance, so that'll be the square root of NPQ. Okay, in the next lecture I'll go through a little example that will allow you to work those out. So just going back over it again, a binomial distribution, there's only two possible outcomes, and they are usually referred to as a success and a failure. And we know that the probability of a success plus the probability of failure is going to be equal to 1. It is made up of doing an experiment where you repeat independent trials n times. And we've worked through Pascal's triangle, how to get the coefficients. Another way to get the coefficients is by using combinations. So one is 5C0 or NC0. This will be NC1, NC2, NC3, etc. Depending on n. Here this n was 5. This allows you to work out all possible. So if you had to do a probability distribution, you could work out all of them there. And this is a way to go straight for a particular number of successes. So it'll be just NCR, which you'll be able to work out because you'll have N and R given to you in the question. P to the power of R, so this is the R successes, Q to the N minus R. And finally, we did mean and variance, is just the number of trials times the probability. Don't forget P does not change in this case. Variance, NPQ, standard deviation, square root of that.